We're going to graph the curve y equals negative cos of 1/3 x plus pi over 12 minus 1. Ultimately, the curve looks like this, but you might wonder how we got there. Well, what we did is we followed these steps. We determined the parent function, and then we determined the equation of the axis, as well as the amplitude, the phase shift, the period, the coordinates of 5 points. And then we graphed, remembering to properly scale the x and y axis. And in this question, we're doing D. Okay, so what we did is we first of all had to factor out the 1/3 in the argument. So 1/3 of x plus pi over 12 is equal to 1/3 of bracket x plus pi over 4. We then determined what our parent function was, and in this case our parent function is y equals negative cos x, because it's a cos curve with a -1 for a coefficient. Well, negative cos x looks like this. It starts at the minimum y value, it then proceeds up to the axis of symmetry, up to the maximum y value, down to the axis of symmetry, and down to the minimum y value again. Okay, so we have a parent function of y equals negative cos x and an axis of y equals -1. Now you might wonder how we got y equals -1. The y value of the axis of symmetry is always equal to the c value. And in this case our amplitude is 1. It's not -1. The amplitude is never negative. So since the amplitude, since the a value is -1, the amplitude is the absolute value of that. Now we know from a negative cosine parent function that our second and fourth critical points will proceed through the axis of symmetry. So the second and fourth points will have a y coordinate equal to -1. Well, the initial y coordinate will be one amplitude below the axis of symmetry. So the first y coordinate will be -2. We'll then proceed up to -1 and up one amplitude to 0. Back down to -1 and then back down to -2. In this case our phase shift will be pi over 4 to the left. And the reason it's to the left is because we have x plus pi over 4 in the argument. The period is going to be 2 pi over 1/3. That's kind of hard to see, but that says 2 pi over 1/3. Now how did we get that? It's because the k value is 1/3, and we always take 2 pi and divide it by whatever the absolute value of k is. In this case, k is 1/3. 2 pi divided by 1/3 ultimately becomes 6 pi. And that's down here in the end. So 6 pi is ultimately our period length. But what happens in one of these curves is we take our period length and we divide it by 4. And in doing that, we come up with 5 key points. The first one is here. The second key point is 1 after dividing the period by 4 to get the length of one interval, we see that our second point will be one interval farther away from the first point. Our third point will be another interval away. Our fourth point will be another interval away, and finally our last point will be another interval away. So although we have 5 points, we divide our period into 4 to get the length of 4 equal intervals. Dividing the period by 4, we get 6 pi divided by 4 is equal to 3 pi over 2. We can then evaluate our 5 x values. The first one is negative pi over 4. That's because the phase shift is pi over 4 units to the left. After that, adding 3 pi over 2 each time gives us 4 more x coordinates here. 5 pi over 4, 11 pi over 4, 17 pi over 4, and 23 pi over 4. From there, we're able to take these 5x coordinates and put them next to the 5y coordinates that we showed you on the previous page, giving us these 5 points. We then want to know what to scale our x-axis. Our x-axis will be scaled at pi over 4 radians. Every one horizontal square will represent pi over 4 radians, because 4 is the lowest common denominator in the x-coordinate column. Our y-coordinate will be scaled for 1 per vertical square, because we're dealing with relatively small integers, so that seems appropriate. And so, putting these 5 points on a graph and drawing the best negative cosine curve we can through the points, we get a curve that looks like that.